Let's talk about converting from grams to grams. So that's the new topic we're going to be doing for this week. We're combining everything we have gone over so far. We're going to need molar mass, going from grams to moles, going from moles to moles, and then we ended up combining this to go from grams to moles to mole. We're now going to go and take it one step further, and from this mole, we're going to be going into the other gram. So it's like going to grams to moles, and then the moles back to grams. It may seem a little confusing, but it's not that bad. So we're going to be using like a roadmap type thing. So I'm going to just write it here. So what we're doing is going from grams of substance A. Doesn't matter what it is, it's whatever we're given. It could be a compound, it could be an element, it could be a molecule. And whatever's given in terms of grams, we're going to convert it into moles. So moles of A. We're going to turn moles of A into moles of B. And then we'll go backwards and then go from the moles of B to grams of B. And B is the substance of whatever you want. So let me write that right here. So you have A is going to be your substance given. And then B is going to be your substance that you want. So instead of saying gram of A, we'll say gram of whatever you start with, mole of whatever you start with, mole of what you need, and gram of what you need or what you want. And for this one, the table that we're going to be using is going to be a little bit longer than the other ones because we're adding one step. So now we're doing 4 boxes like this. And what goes in each box is going to be this. So that's why this is important, and I'm going to write it in. It's on every single slide of the examples that we have over here. Because we're just going to take this, the way you see it, and we're going to put it in our boxes here at the top. So this box is going to be gram of A. This box is going to be mole of A. This one is going to be mole of B. And this one's going to be gram of B. All we're going to do is put numbers in the fronts, and then instead of saying A and B, we're going to put in whatever compounds we're talking about. And then for the bottom part, we know that whenever we write something on top, we write it at the bottom. So because gram of A is here at the top, gram of A goes here at the bottom. Mole of A here at the top, so mole of A goes right here at the bottom. And mole of B on top, so mole of B has to go at the bottom. That way we can cancel off all these units, and we're left with just what we need. Another cool thing and easy, something you guys want to do as you're writing in or filling in your table is as soon as you write it, this is always going to be 1, and this one's always going to be 1. Because we're going to be using molar masses, and when you're talking about molar mass, is always grams per 1 mole. So that will be a 1, that will be a 1. In terms of the other boxes or other sections, so this is your given. So we're going to write here, we know that this is always given. The last box, this is always what we want. But we have column 1, column 2, oops, and then column 3. And for each of those, you're going to need different things. So for 1, what we're going to need for this box right here is going to be molar mass of substance A. In the column right here for number 2, we're going to need the mole ratio. And this is pretty easy. All it is just writing in the numbers from your balanced chemical equation into each of those things. And you'll see it when we do the examples. It's the easiest thing to put in. And then for the last column, this box right here, the thing that you want is going to be molar mass of substance B. So that's going to be our setup. So this is what we're going to be doing. Okay. So let's go over to example 1. So we're going to start off with like easy equations. So this is my equation. We're going to be using water. So the equation for water is 2H2 plus O2 gives you 2H2O. And I wrote the map here. You should already have it from the last slide. But I have it here because we're going to need it, and I'm going to use that to fill in my table. And the question is, if you have 10 grams of H2, how many grams of H2O can you produce? So if you have 10 grams of H2, so this is my given, because it gives me this quantity. How many grams of H2O can you produce? So how many grams of H2O? So this is what I want. And what I'm going to do is I'm going to identify what's what. So for my given, it gives me H2. So this is what A is going to be. So instead of saying gram of A, I'm going to say grams of H2. And B is what I want. And I want grams of H2O. So H2O becomes my B. So instead of saying B, I'm going to put in H2O. So with that, I can go ahead and set it up. So I'm going to do my long table. I'm going to need 4 boxes. 1, 2, 3, 4. I'm going to start filling it in with what I'm given. So I have 10 grams of H2. So that's given. And then the next step is to go to moles of A. So this one is moles. And instead of saying A, my A is what? H2. So H2 goes right there. The next box is mole of B. Mole. And instead of saying B, this is what I want. I want H2O. So mole of H2O. And then the last box is going to be grams of B. And then again, B is H2O. So my top is filled in with the units. All I have to do now is fill in the bottom. But the bottom is just taking the top, putting it at the bottom. So gram of H2 is right here. So I need to put gram of H2 at the bottom because I need them to cancel. Mole of H2 is at the top. So I need to put mole of H2 right here at the bottom. And then I'm going to take mole of H2O from the top and put it right here at the bottom. So my units are filled in. Now I can start plugging in my numbers. But before I do that, I can go ahead and put a 1 right there and put a 1 right here. Those ones are never going to change. Those will always be 1s. So as soon as you fill in your units, put them in. The next piece, the next easy part, is to do the middle section right here. Moles and moles. This is mole ratio. All I have to do for the mole ratio for column number 2 is mole of H2O. I need to look at H2O in the equation right here. In front of it, there's a big 2. So that 2 I'm going to write right here. I do the same thing for H2. H2 is right here. In front of it, there's a big 2. So I'm going to take that 2 and put it right here. Last thing I need to do is fill in this box and then fill in this box. So those are just molar masses. So this is the grams of H2. So what is the total amount of grams of H2? So let's find molar mass. So H2, I have 2 H's. Each H weighs 1 gram. So that means that 2 times 1 is 2. So the mass of H2 is 2 grams per mole. Last one I need to do right here is H2O. So let's break that one down into molar masses. So H2O has an H, it has O's, 2 H's, 1 O, multiplied by the mass. So in the periodic table, H is 1, the mass of oxygen is 16. 2 times 1 is 2, 1 times 16 is 16. So overall, my mass for water is 18 grams. So that goes right there, 18 grams per mole. And this is the hardest part. The hardest part is setting it up. Once you have it set up, the rest is just easy math. You just multiply straight across after each line. You do the top across and then the bottom across. And then once you have that, you just divide your top number by the bottom number. So now let's look at the units. gram of H2 cancels with gram of H2. Mole of H2 cancels with mole of H2. Mole of H2O cancels with mole of H2O. So the only one that doesn't cancel is grams of H2O, and that's what I want. I want to find grams of H2O. So let's plug in our numbers. So at the top, I get 10 times 1 times 2 times 18 divided by, in the bottom I have 2 times 2 times 1. So I'm going to plug them into the calculator. So I get 10 times 1 is 10, times 2 is 20, 20 times 18 is 360. Divided by 2 times 2 is 4, times 1, 4. So now I just got to divide the top and bottom. So 360 divided by 4 gives me 90. But don't forget, we still need to write the unit. So 90 what? The only one that didn't cancel was gram of H2O. And that's our answer right there. So if I have 10 grams of H2, I end with 90 grams of H2O. So 10 grams of this gives me 90 grams of this. So hopefully it's not that bad. So we're going to be doing a few more examples, but it should be doable. The hardest part, like I said, is just the setup. Once you get the setup done, the rest is just basic math. So example number 2, we're going to keep the formula for water. So still H2O. I mean, it's 2H2 plus O2 gives you 2H2O. Again, this is just the roadmap formula that I'm going to take to fill in my table. So just use that. You should already have it in your notes. But you can rewrite it if you want to, I guess. So now here's the question. If you have 128 grams of O2, how many grams of H2O can you produce? So if I have 128 grams of this, how many grams of this can I make? Similar question to the last one. So let's see. If you have 128 grams of O2, so this is my given, how many grams of H2O can you produce? So this is what I want. So that means that in my given, the O2 is my A, the H2O is my B. Let's do our table now. Let's set it up. So given, first box, I have 128 grams of O2. Next box is mole of A, so mole of O2. Third box, mole of B, so mole of H2O. And the last box is gram of B, so gram of my B is H2O. Okay, so that's filled in. So now I can go ahead and put my bottom one. So just take the top and bring it down. Take the top and bring it down. And right away, I'm going to go ahead and put a 1 right here and put a 1 right here. Now, next one, I'm going to do the middle section, mole. So again, all I have to do is find H2O in your equation. So H2O is right here. In front of the H2O, there's a 2. So a 2 goes right there. Find O2. O2 is right here. There isn't anything in the front. That was just a smudge. So if there's nothing in the front, there is an invisible 1. So 1 goes right there. Now with that, all I have to do now is fill in my molar mass of O2 and the molar mass of H2O. So let's go ahead and find the mass of each one. I'm just going to do it right here at the bottom. That way, if my video cam thing is on that side. You can see the work. So for this box, I have O2. O2's oxygen, right? I have 2 oxygens. The mass of each one is 16. So the total mass of O2 is 32. So 32 goes right here. So 32 grams of O2. We already found the molar mass of water. That was in the last example. But let's just do it here just so that we can have it. So H2O has H and O. 2 H's, 1 O. Mass of H is 1. Mass of O is 16. So 2 times 1 is 2. 1 times 16 is 16. So the total mass of water is 18 grams. So 18 goes right here. So now those are my molar masses. I'm going to use this space right there at the bottom, so I'm going to delete it. But just make sure that you guys have it in case you need it. You can do it in your head. That's fine. Just double check your work. If you get the molar masses wrong, obviously your answer is going to be wrong. So next, unit cancel. Grams cancels with the grams. Moles of the O2 cancel with the moles of the O2. Moles of H2O is going to cancel with mole of H2O. So what I'm left with is 128 times 1 times 2 times 18 over, at the bottom I have 32 times 1 times 1. So let's plug these, let's plug them in, and we get 4,608 right here over 32 at the bottom. So all I got to do now is divide top and bottom. So 4,608 divided by 32 gives us an answer of 144. So 144, and the unit, whatever didn't cancel, gram of H2O. And that's the answer for that one. Hopefully it's not that bad and it's doable. Just watch your numbers. Setup is the hardest part. Once you get the setup done, you're good. Okay. For all the examples that I'm doing, I use numbers that are going to give me a whole number at the end for the answer, so that way it's easy to check. If you end up getting decimals, something happened. Double check your numbers. Something went wrong, especially for like the practice problems that you will be responsible for. But just check those out. And I'm going to do one more. I'm going to do the salt one. I'm also going to mix the question. You don't always start with your given. Sometimes you can start with the want. So just be careful. Just make sure you read the question first. The how many part is what you want. So whatever number it gives you, that's part of your given. So here's the example. So here's the next one. We're going to be using the equation for salt, sodium chloride. So that's right here. So 2Na plus CO2 gives you 2NaCl. This is just the roadmap again, just so that you can see where I'm getting each box from. Now the question says, how many grams of NaCl can be produced from 48 grams of Na? So right away, so this is a quantity that's been given to me. So that means that this is my given. And how many grams of NaCl? So how many grams, that's the question. So this is what I want to find. So this is what I want. So now, because this is what I want, this is the B. And so this is given, Na is going to be the A. So that way I can just substitute those in to my equation. So now let's go ahead and set it up. So I get my 4 boxes. I'm going to start with my given. So my given is 46 grams of Na. Next box, I need to convert it to mole of A, and A is Na, so I can put Na right here. The next step is getting mole of B. So mole, but instead of saying B, I have NaCl. And the last one after that, I need to go into gram of B. So gram of NaCl. So now that my top one is done, I can go ahead and take the top units and just put them on the bottom. Take the top unit, put it at the bottom. Top unit, put it at the bottom. And right away, one right there, one right there. Now for the next numbers, I'm going to do the middle section right here. Mole, I just need to look at the equation. NaCl is right here. In front of it, there's a big 2. So 2 goes right there. Next, I have Na. In front of the Na, there's a 2. So a big 2 goes right there. From here, all I need to do is write in the molar mass of Na and the molar mass of NaCl. Na is going to be easy because it's just an element. I do not need to add anything together. It's just whatever the mass of Na is. And the mass of Na from the periodic table is 23. So 23 goes right there. I do need to find the mass of the NaCl though, so let's do that. NaCl, I'm combining Na with the mass of Cl. So Na and Cl. I have 1 Na, 1 Cl. This is chlorine. It's not a C and I. That would be carbon, iodine, Cl, chlorine. It's by itself. Now the mass of sodium is 23. The mass of chlorine, if you're using the old periodic table with the decimals, is 34.45. But I'm not going to use that one. I'm going to use the second one that I gave you, the one that's rounded and is being rounded to 35. That way we don't get decimals and it makes the math easy. It's just a concept. 1 times 23 is 23. 1 times 35, 35. So the total mass of NaCl is 58. So that's the amount of grams of NaCl. So that goes right there. And again, I'm going to use the space right here. So I'm going to delete this. Make sure that you have it. And from here, I can start to cross off the units. So grams of Na cancels with the grams of Na. Moles of Na cancels with moles of Na. Mole of NaCl is going to go ahead and cancel with mole of NaCl. So what I'm left with is 46 times 1 times 2 times 58 over 23 times 2 times 1. So once I plug those in, at the top I get 5,336 over 46. So once I divide those, I get total of 116. And again, the unit is whatever I wanted, whatever didn't cancel from the first step right here. So my answer is 116 grams of NaCl. And that's it. That's all this is. Just the hardest part is just setting it up, and it shouldn't be that bad. Given, one here, one right there. The middle section is just putting in whatever the equation gave you, the balanced equation. Make sure that it's balanced first. I will give you balanced ones, but if you see this again, they're not going to be balanced in future classes. So put this in, and then the last two boxes, this one and this one, is just finding the molar mass. So add up the total masses of each thing, so if it's a compound or a molecule. If it's just an element by itself, the way that Na was, then it's just going to be the molar mass of the atom or the element that you have. And now for the practice problems, there's 2 of them, and it's going to be the same equation for NaCl. The way the setup for the question itself is like this. So all I'm doing is changing like your A's and your B's, and then the number. But the setup's going to look like this. So for number 1, the question is, how many grams of NaCl can you make from 140 grams of Cl2? So this one, be careful. There's 2 Cl's. It's not C and I, so don't combine them. It's chlorine, the one that weighs 35 grams. And question number 2 is, how many grams of CO2 do you need to react with 92 grams of Na? Remember that right here in front of the Cl, there is an invisible 1. So when you're putting it into the mole ratios, make sure that you put a 1 for your moles of CO2. You should get whole numbers. If you're getting a decimal, something went wrong, so check your work. Check the masses, and also make sure that you put the right numbers in front from the equations. If you got like a 0.5 answer, then something happened somewhere where you didn't double something that you should have. So just check. If you have any questions, you can just let me know. And good luck.